Welcome to the notes on employee benefits, specifically how we figure out employee vacation benefits. So when you start to work full-time, one of the perks that you're going to have is vacation, and some businesses, a lot of businesses provide paid vacation time. So for this particular example, we have Marilyn. When she was hired, she was told that she had 3 days of paid vacation for each year that she worked at the magazine. She would gain another 2 days of paid vacation to a maximum of 26 days. So what we have here is the day she signs the documents and is employed with this company, she has 3 days of paid vacation right off the bat. And then after each year she works, she gains another 2 days of paid vacation. So what we have here is an equation. We have a certain amount of days given to them in the beginning, and then they gain 2 days of paid vacation each year that they work. So here we have she was given 3 days of paid vacation, and here we have each year she worked, she would gain another 2 days of paid vacation. So really what you have is you have a rate of 2 days of paid vacation and then a given 3 days paid vacation, or you have a starting amount or y-intercept. So the 3 days that she was given would act as the y-intercept because that's what she starts with. Remember, y-intercept is whatever you start with. And the 2 days per year, or 2 days she gets per year, would act as slope. And so that's the m. So we can write an equation for this. Y equals the 2 days she gets every single year would act as the rate or slope, so 2x. And the 3 days she was given in the very beginning would be your y-intercept. So then you can use this equation to figure out how many days of paid vacation she would have for any amount of years. So in this case, it says, well, how many does she have after 10 years of employment? You simply just put the 10 in for x. 2 times 10 plus 3. 2 times 10 is 20, and then plus 3 would be 23 days. So Marilyn, after 10 years, would have 23 days of paid vacation if she weren't able to, or if she wasn't using it. Example 2, Alden works for a printing company, and he has been a little over 4 years since he was hired. When he was hired, he was told that he had 5 days paid vacation. Again, just like the previous problem, when he was hired, the day he was hired, he was given 5 days. And then each year he works, he gains another 2 days of paid vacation time to a maximum of 20 days. So in this case, we're going to fill in a data table as well as write the equation. Now, it may be easier actually to find the equation first. So again, y equals, okay, each year he gains 2 days of paid vacation, so 2x. And then he was given 5 days of paid vacation, so 2x plus 5. Then simply, after 0 years of work, 1, 2, 3, 4, and whatever, you can just plug those in for x. So at 0, 2 times 0 would be 0, plus 5 would be 5. And then 1 times 2 is 2, plus 5 is 7. And you get the pattern. It just adds 2 every single year. So you can just do 9, 11, 13, 15, 17, and 19. And then we graph it. And you can see that is a linear equation. To analyze this graph a little further, it says, what does the y-intercept mean? Well, the y-intercept is the 5. So what does that represent? It just represents, the amount of vacation days that he started with. Remember from algebra that the y-intercept is always whatever you just started with. The slope would be the rate. It's the number of days he gains for every year that he works. And then lastly, it says, how many paid vacation days does he get after 4 years of employment? You could just look at the graph up above, or I could plug in 4 to the equation. 2 times 4 plus 5 would be 13 days. Now here is where things get a little more complex. As a part of the analytical standards required by the state, we do have to show you another way of doing the same thing, and that's through using sequences. So these formulas that you have here for recursive and explicit formulas will always be given to you. You will not have to memorize these. All you have to know is what each one means. So in the recursive formula, a n equals a n minus 1 will be standard. You don't have to do anything. There's nothing you plug in for a n equals a n minus 1. The only thing that you would find and plug into the recursive formula is d. And d represents the common difference. Think of d as the slope. It's the same thing. Whatever the rate at which they're gaining days, that is going to be the d, the difference, or the slope. So same thing. If what we did above here made sense in defining the slope, d is the same thing. It's the slope. Okay, it's whatever the rate is. In an explicit formula, you have two things you need to put in. The a sub n is going to stay the same, equals a sub 1 equals or plus n minus 1 times d. Now the d is the same d from the recursive formula. It's just the slope or the rate at which it's changing. The only additional thing you have to find is the a sub 1. And all the a sub 1 is the first term. It's just whatever the first number is, the first term in the sequence. So this is seriously going to take some practice. So if we get through this, don't freak out if you don't know what you're doing. This is one of the more complicated things that we do. This probably is the most complicated thing we do in Unit 1. So if you don't get it, it's okay. We'll go over it next class as well. So here's our example. Lester works for a cable company, and when he was hired, he was told that he had 5 days of paid vacation time. For each year that he worked at the company, he would gain another 2 days of paid vacation time. So same problems as we did above, we just have to write it a little bit differently. So assuming that Lester never used his vacation days and was allowed to carry them over each year, write a sequence to represent the number of Lester's paid vacation days. So when we say that he was given 5 days, so he has not worked a year. So he has not even worked a day yet. He signed his documents and he was given 5 days. He didn't even work any days. He didn't work any years. So we call that a sub 0. It means that that's the number that references before anything even starts. It's before time begins. He got 5 days before he even started working. And then the rate, the 2 days he gains each year, instead of being m like it was in the previous equations, here in these type of equations it represents d, but it's the same thing. So you have the starting amount and you have d. So all we have to do to find the equations is just plug them in. So it's going to have us write a sequence. So when you go to write a sequence, you're just going to write, okay, well, he starts off with 5. What would he have next year? What would he have the year after that? Then the year after that? Well, the first time he would have 5, and then he would gain 2, so it's 7. Then he would gain 2, that's 9. Then he would gain 2, and it's 11, and so on. The first number represents time 0, or a sub 0, because time hasn't even started yet. So when you're looking for a sub 1, it technically, actually, in this sequence, is the second term, not the first term. So when we go to write a recursive equation, we're just going to copy the equation from up above. There's the equation. Remember, in a recursive formula, the only thing that you need to find is d. So you're just going to find d, and it's already given to you. D is the slope. D is m. It's the rate at which you're gaining days. In this case, it's 2. So your answer would just be a to the n equals a to the n minus 1 plus 2. That's it. Literally, that's it. All you have to do is find d, plug it in there, and you're done. B is done. For the explicit formula, and a sub 0 equals 5. For the explicit formula, we're going to bring down the explicit formula. And remember, the only thing that we have to do is find d and a sub 1, which if you wrote the sequence down above, you already have those. Okay, a sub n, a sub 1 is 7, because that's above, plus the n minus 1, and then d is the same d from above, is 2. Now for this, we have a little bit of work to do. We can't leave it like this. We do have to simplify the problem. So we do take that 2 and distribute it into the parentheses. When you distribute that into the parentheses, you get a sub n equals 7 plus 2n minus 2, and then you can combine the like terms, 7 and negative 2, to be a sub n equals 5 plus 2n. Okay, I know that's a lot. You're like, what the heck did we just go over? This is something that is definitely going to take some practice. So if you don't get it right away, don't freak out. I promise. It will get easier. We do this a few more times. So we have one more example here. And so this one, we give you the sequence already. We give you the sequence already. So all you have to do is just label it. Now this doesn't give you how much she started with. So we're going to assume that the first one is the first term, because the problem doesn't tell you that they start out with this many days. It just says that here is the amount of days they had at the end of each year. So it's going to be 1, 2, 3, 4, 5, 6, 7. Okay. Now, this part here deals with something called summation notation. Summation notation is sigma. I don't know if you're familiar with the Greek letter sigma, but that means sum. And basically what it means is you're going to add up all of those numbers. So the first number will represent year 1. And so step 1 is going to be to find the arithmetic equation. So it's the same thing above in C above. So we take the a sub n equals a sub 1 plus the n minus 1 times d. Remember, all you have to find is a sub 1 and d. A sub 1 is the first term, which is 3, and d is the common difference. So it looks like it's gaining by 2 every time, so our d is 2. Again, you distribute into the parentheses, since you have 2n minus 2. Combine your like terms, the 3 and the negative 2, combine to be 1, and then plus 2n. So now I have my formula. I can now write it in summation notation. Step 2 is summation notation. So I start off with sigma. That's what a sigma looks like. That's the summation notation. On the top is the total number of numbers. So since there are 7 numbers, a 7 goes on top. And since it starts with the first number, on the bottom you put n equals 1. It starts with the first number, ends with the 7th number, and so that's what that means. And then the formula goes right next to it. Now, don't worry about this part. Desmos will do everything for you here, so you will need to have Desmos. I want to split screen it. There we go. So what we can do with Desmos here is put in this summation notation. If I bring up the keyboard here, so we're going to go to the functions on the far right, and it's under the miscellaneous thing is the summation. Now the only problem here, and I know we have n equals here, but Desmos doesn't really like to do math with anything other than x's. So we're going to change that. Instead of n, we're just going to use x instead, but everything else will stay the same. We're going to change our n to x. So this will be x equals 1. X equals 1, and the top will be a 7. And then we'll do our formula 1 plus, but instead of 2n, we'll just do 2x. And so, and then you have to put it in parentheses. And when you put in parentheses, it tells you the answer. Desmos spits out the answer that you would have 63 days. So over here, we can type it in just like that, except for instead of n's, you have to put x's. And then you also have to put it in parentheses. but it gives you 63 days. That after 7 years, she would have 63 days of paid vacation.